Hi everyone, welcome to the rest of our 6.5 lesson. This is just an optional lesson. I'm going to cover two more examples of calculating slope, one from a graph and one from a set of points. And this is just a little bit of practice on if I am given a graph, or I'm given 2 points on a line, how do I figure out the slope of that line? Okay, so again, there's two methods. One is counting the rise and counting the run, and the other method is to use the slope formula. So let's go ahead and do both for this graph that we have here. So on our note 6.5, this is example 4. So the first thing I need to do is I need to pick 2 points, no matter what method I'm using. And the 2 points that you're going to pick have to be points that you can clearly see the coordinates for. So we're going to pick 2 points that fall on the grid lines. And again, any points that are easy to read for you are good points to pick. So for example, you might pick this point here. Okay, you could also pick the point 0, 2. That's a really good point. I could also pick this point down here. That's a great point to pick, or even this point down here. Okay, so there's lots of points there. Let's just go ahead and pick 2. Let's pick this point right here. Let's call that point 1, and let's call this point 2. So again, it doesn't matter what 2 you pick, you're going to get the correct slope. And I'm going to count. I'm looking left to right, and I have to find the rise, and I have to find the run. So remember that slope is equal to the rise over the run. And so the rise is the change in y. So I'm asking myself, by how many do I have to go up or down to get from point 1 to point 2? Well, I can see that I have to go down all the way to here. There is my rise. My rise is negative. It is, I'm going down 1, 2, 3, 4 points from 4 to 0. So my rise is negative 4. And my run is going to be how many divisions on my x-axis do I have to go over to get to point 2? So there's my run. And let's see, my run is, I'm down here at negative 3, and I have to go 1, 2, 3, 4, 5, 6 in the positive direction. Okay, so it's going to be 6 is my run. I'm going from negative 3 to positive 3. Okay, so I go ahead and I can actually reduce this fraction. So 4 and 6, if I want to get that into lowest terms, and I should, 4 and 6 are both divisible by 2. So let's just reduce this by 2. So we get, this is the same as 2/3. 4 over 6 is the same as 2/3. There is a negative sign out front because my rise was negative, and so my slope is negative 2/3. Okay. We could also use the slope formula. Slope formula looks like this. Our slope, which we call m, okay, slope is equal to the change in your y. So it's y2 minus y1 over x2 over minus x1. So it's the difference in my y values over the difference in my x values, which is just the change in y over the change in x. And it's for any 2 points. So the points that we picked were, just to show you how, those are the 2 points I picked. So let's go ahead and use them, okay? But you could actually use any 2 points on this line, as long as you can clearly see what the coordinates of those points are. So the 2 points that I picked point 1, and if I look at the coordinates of that point, it's back 3 on my x. So point 1 is negative 3 for x, and the y value, the y coordinate is positive 4. If I come over here to my y-axis, that's at positive 4. So that's point 1, negative 3, positive 4. Okay, that's 1 point. And the other point that I picked, let's have a look at my graph. I picked point 2 down here. Okay, and if I look, let's see, what are the coordinates of that point? It's positive 3 for x. I have to go over 3 on my x-axis, and it's at 0 for y. So 3, 0 is point 2. Okay, now I'm going to go ahead and I'm going to identify, looking at my formula here. So negative 3 is the x value for this point, and 4 is the y value. So let's call this point, this was point 1, so let's say that's x1 and that's y1. Okay, and the next point, we call it point 2, so let's say that's x2 and that's y2. Okay, x always comes before y when you're looking at a point on a graph. So now we're going to substitute those values into our formula, and it's going to look like this. y2 is 0 minus y1, which is 4, Okay, x2 is 3, and I have to subtract negative 3, that's x1, and remember that's a negative 3, so I keep the negative sign with it. I'm subtracting a negative, so my slope is equal to, on the top I have 0 minus 4, which is simply minus 4, negative 4, and on the bottom I have 3 plus 3. I have positive 6 on the bottom. Okay, so I have 4 over 6, and again that can be reduced because both 4 and 6 are divisible by 2, so I could reduce this. If I divide the top and bottom by 2, I get negative 2 over 3. Okay, that is my slope. My slope is equal to negative 2 over 3. So I get the same answer no matter which way I do it. And again, you could have picked any 2 points on this line. So we just happen to pick those 2. Let's do an example now just where I'm not given a graph at all, so I can't use the rise over run method. I do have to use the slope formula. So on the following example in your notes, example 5, all we're given is 2 points. Now you could go to the trouble of taking out some graph paper, plotting those points, connecting them by a line, but again, there's not a lot of value in doing that. That's just a lot of time. You can quickly use the formula here for this. Okay, so to find the slope is equal to y2 minus y1 x2 minus x1. And again, it doesn't matter what point you call point 1 or point 2, as long as you're consistent. If you call this point 1, then make sure you label this one x1 and this one y1. Okay, that's all that matters. If you choose to make the other point 1, that works as well. Just be consistent. Make sure the one you labeled 1 and 2 are the ones that you're plugging into your formula. You'll still get the same answer. If I call this point 2 then, just makes sense because it comes after the first point, then the x value here, the first number, negative 4, will be x2, and the second number, 3, will be y for point 2. So there's x2 and y2. Now we can go ahead and plug those in. So y2 is the y value for point 2, that's 3, minus the y value for point 1, which is 8. Okay, and on the bottom I have to put x2, so that's negative 4, and, sorry, no comma. And then I'm going to subtract x1, and x1 is negative 7. So when we have a negative value, I have to make sure I write that value in as a negative. So it's subtracting a negative. And what we get here is, on the top I have 3 minus 8. 3 minus 8 is negative 5. And on the bottom I have negative 4. Look what happens on the bottom. A negative subtract a negative, okay, is a positive. So negative 4 plus 7. And that's going to give us negative 5 on the top over, let's see, negative 4 plus 7 is the same as 7 minus 4. That's going to be positive 3. That's my answer. So my slope is negative 5 over 3. I'll write that out nice and clearly here. Okay, there's my final answer. That's my slope. I want to show you something. If you decided to, say you had switched those points around, okay, you don't have to write this down, but just to show you, if you had called the point negative 7, 8, if you called that point 2, okay, and you called the second point that we had there negative 4 and 3, if you had called that point 1, you still get the right answer. So there's no wrong way to go about this. Okay, let's just imagine I did that. So the first set of x and y values would be 0.2, so that would make this x2, and that would make that y2. Okay, so I'm just switching them. And this other point here, 0.1, okay, would mean that negative 4 is x1, and 3 is y1. If I put those values in to my formula, y2 minus y1, okay, I'll get 8 minus 3 over x2 minus x1, so negative 7 minus negative 4. Let's see what happens. 8 minus 3 is 5 on the top, and on the bottom I have negative 7 plus 4, which is negative 3. Okay, this negative sign right here on the 3 needs to come out front. Okay, and really over here in my slope 2 I have this negative 5. that negative sign can come out front. Okay, it's fine to leave it on the 5. It's also fine to pull it out front. Okay, so the same thing happens here. I pull that negative sign out front, and it is 5/3. That's my slope. So it really does not matter which way you label your points, as long as you use the formula correctly and you're consistent. Okay, I'm going to stop it right there. So I've done 2 more examples with the slope formula and 1 with the graph. I will do this last example here, which is just another graph. The only difference with this graph is it's for a problem where we have distance against time. So this is a good one to look at. Sometimes the slope actually means something. In this case, it means change in distance over change in time, which is equal to speed. So I'll do this last example and then just in the next video. And again, this is optional. So if you feel like now you're feeling ready to try some of your 6.5 questions, go ahead. Okay, you can watch this next one as well. Thanks for joining me. Bye for now.